Hi, in this video, we're going to solve a particular problem which appeared in JEE Advanced 2016. Here, we have a function fx given as a summation of cos and sine function with, right, that a b two real number is present, and we have to test that if the function is differentiable or not differentiable at different given values of a and b, right, at x equal to 0 and 1. These two things we need to test it out. So let's go ahead and solve the particular problem. We have that argument of cos function and sine function will be in modulus form, and we have x cube minus x and x cube plus x. So therefore, first we try to understand these two functions, right, and then we'll proceed for this problem, right. So let's go ahead. So notice that here that we consider the function gx is x cube minus x. So if we factorize, it will be x into x plus 1, x minus 1, which gives us the zeros of this function are equal to -1, 0, and 1. That's why if we plot the gx function, it will intersect the x-axis at the point -1, 0, and 1 itself. Now we go ahead and find out a values, arbitrary values. So here we consider the values of g minus 2. So which is calculated as -6 less than 0. Now why we do so? Because these three information are required to sketch the function gx. So here we consider the x-axis and y-axis and mark the point -1, 0, and 1 respectively. Now notice that g of -2, right? G of -2 is equal to -6. So -2 is -6, right? That's it. Now, how we sketch it? Now see that this from here, the graph of gx must be go up, right? Otherwise, it will not intersect the x-axis. So I just make the appropriate drawing and it is go up, right? Now, it should take a turn and come down. Otherwise, it will never cross at x equal to 0. So it goes up and it's come down. Again, with the same logic, right, it will take turn and goes up, right? And that's it, right? Because if there are any other roots, right, so then it should come up and all that stuff, right? So basically, this is a sketch, right? We cannot guarantee that, right? This is the exact plot, but in this case, yes, because it's a polynomial, but complicated function by root, we can do that. Now, if we want to get the exact interpretation, right, we have to take, right, the limit as well. So if I take the limit, right, limit x tends to infinity, x cube minus x will be equal to plus infinity, obviously. And if I go ahead and take x to minus infinity, x cube minus xlb gives us minus infinity, right? How we calculate very easily, right? This is not whatever we are saying. It's not a mathematical way, right, to understand the limit. But let's go ahead for infinite, right? So it's infinity. To take that, it's infinity, right? So infinity cube minus infinity. What is infinity cube? I can say that it's infinity. Again, it will be infinity. So therefore, that infinity cube term as it's present, so it will be plus infinity. For minus infinity, right, it will be minus infinity whole cube plus infinity. So minus infinity whole cube means that it will be minus infinity. Okay, that's it. If we want to go ahead, just take that x cube common and do that analysis, we'll get that stuff, right? That's it. Let's go ahead. So here we draw the function of gx, right, which is x cube minus x. For the function of x cube plus x, we consider that and factorize, which gives us the roots are only x equal to 0. Why? Because x squared plus 1 is definitely a roots, but it's not the real roots. Because for the real roots, x squared plus 1, it's the -1, so plus minus I. That is not acceptable for sketching, right? That's it. So here we go ahead and compute, right, that h of -1 again, which is equal to -2, which is less than 0. So based on the previous logic, right, we can easily draw the graph of hx. So these are the graphs for hx and gx, and this is very crucial to solve that particular problem very faster way. Let's go ahead. First we take option A. So here A is 0, B is equal to 1. So therefore, if A is 0 and B is equal to 1, so therefore, this cos of x cube minus x term will be deleted or omitted, right? So therefore, our given function will be equal to mod x and sine x cube plus x. So now we have to test for the differentiability. Now, first, to go ahead and test the differentiability, first we rewrite the function because that's the easiest way to go ahead. Otherwise, we have to calculate that limit using the definition of limit. We need to calculate the right derivative and left derivative, which is much time killing and time consuming, and it's not that easy for this problem as well. So that's why we go ahead and rewrite the function now. Okay, so let's go ahead. So here we notice that case, right, that we need to test the differentiability at x equal to 0, right? So that's why we consider a small neighborhood, that means the area close to, okay, that 0, right? So we say that x belongs to 0 to h, and where h is very small, that's why h is tends to 0, but is positive. So in that case, right, we can define what is our function. So here we notice that x cube plus x is greater than 0. So that's why mod of x cube plus x will be x cube plus x as well. So if I take the sign, it will be that sine x cube plus x is equal to sine function. So mod function is deleted now. Also notice that when x is greater than 0, because x belongs to 0 to h, x greater than 0, mod x is equal to x. So therefore, fx will be a simple form x sine x cube plus x. So this is the definition of fx when x lies in the marked region. But here, as it is 0 plus region, right? So that's why we redefined as a plus x. Okay, that's it. Now we consider the region, right, that x belongs to minus h 0, right? So therefore, when we say that it will be minus h to 0, right? So therefore, we can say that in this particular region, right, x cube plus x is less than 0. Hence, we'll say that x cube plus x is equal to minus x cube plus x, right, which have a minus sign. If I apply the sign from both sides, we get sine minus x cube plus x. And we know that sine of minus theta, for anything sine of minus theta is equal to minus of sine theta. So therefore, it will be equivalent to, right, minus of sine x cube plus x. Also, when x less than 0, mod x is equal to minus x. So therefore, if minus x here, right, so if 0 minus case, right, it will be again take the same function x and sine x cube minus x. So therefore, we identify that near the region of 0 or the neighborhood of 0, fx will have the similar form, right? So a plus and a minus x will have the similar form, right? So therefore, we can say that the function is differentiable, because if the function looks like a similar nature, right, and if one is x sine x cube plus x, it's a very simple function. So therefore, by observation only, without testing the right and left limit, we can conclude that the right and left derivative will be equal, right? If you want to find out, let's do the differentiation. So if we do the differentiation of this function using the chain rule and apply x equal to 0, we'll get the value. But here the values are not equal. So that's why here we'll conclude that the function fx is differentiable at x equal to 0 for a equal to 0 and b equal to 1. And that's why option A is correct. Now, our job is to test for option B. So let's go ahead. So now we go ahead and test for option B. Let's go ahead. So here says that A equal to 1, B equal to 0, and we have to test the differentiability at x equal to 1. Let's go ahead. So here we take A equal to 1, B equal to 0, so therefore fx will be equal to cos of x cube minus x. Now, we need to test for differentiability at x equal to 1. So that's why we first consider the region, right, close to A, so that 1 to 1 plus h, where h is tends to 0. Now, in this region, x cube minus x is greater than 0. So therefore, mod of x cube minus x must be equal to the same thing, x cube minus x. If I take the cos value, it will be the cos of x cube minus x. Now here, right, we can easily see that then a plus x will be cos of x cube minus x in this region. So a plus means that in the region, right, in the region, or in the shaded region, right? So 1 plus basically we are talking about. Now if we go ahead and take the limit in the other side, right, or like we can say that neighborhood region of x equal to 1, we'll say that it will be 1 minus h to 1, h tends to 0. So here x cube minus x less than 0, and therefore cos of x cube minus x will be the cos of x cube minus x. Why? Because cos of minus theta is always equal to cos theta. So a minus is also a cos of x cube minus x. So for this particular case, right, also we notice that in the neighborhood of 1, a plus x and a minus x are equal. Now, as they are equal, so therefore we can say that the function is differentiable, because left and right limit must be equal for fx at 1, okay, for a equal to 1 and b equal to 0, and that's why option B also correct for this case. Now see that here we are achieving this right and left derivative concept of equality by stating that function is equal, right? So what that means? It's saying that, right, that near the point 1, right, whatever the function definition in the left hand side, it will be the same definition in the right hand side, right? So therefore, if I derivative at that particular point, right, it will be definitely get the same derivative, right? Or in other way, right, we can say that if I derivative in that particular region, right, so basically we are trying to find a plus dash, right, what we'll get at 1, we'll get slope of the tangent at the case fx, right? So therefore, right, it's saying that, right, both the cases a plus and a minus, slope of the tangent, right, at the particular point 1 will be same. That means we'll get only one tangent. So that analysis gives us the differentiability exists. So that's why we can say that when the differentiability fails, mostly 90% cases, right, I'm talking about, right, if you get a curve, right, when we have a sharp end, right, so then the differentiability fails, right? So this is called the sharp end. Now, what is the meaning of this case, right? The sharp end. It means that, right, that for this particular case, right, we have two tangents. So this is the one tangent. If we go other way around, this will be the another tangent, right? So there will be two tangent, right, for at the same point, and that's why the differentiability exists. And obviously, the for if the continuity doesn't satisfy, right, so the differentiability we don't analyze, right? That's it. So that's the part B, right? Let's go ahead for part C now. For part C, again, A1, B0, so fx equal to cos function, and we have to test the differentiability at x equal to 0. So as we need to test the differentiability x equal to 0, first we consider the region 0 to h, where x cube minus x less than 0, cos of mod function will be cos of minus x cube minus x, and as cos theta is equal to cos minus theta, using that concept, a plus x is the cos x cube minus x, and for the left hand side, minus is to 0, x cube minus x is greater than 0, so cos function will be always cos of x cube minus x, and if minus x is equal to x cube minus x as well. So therefore, we can, using the same definition, we can say that in the region minus is to h, right, a plus and a minus is equal, and therefore the function is differentiable in the neighborhood of x equal to 0 when a is equal to 1 and b equal to 0, and that's why we'll say that this particular function is not differentiable at 0 is a false statement. So that's why option C is not correct. So see, that is the same thing, right? And obviously in exam we don't have to do this all the details. It's just a rough calculation and you can achieve that. Okay, so that's why it's very easy problem. Let's go ahead and test the last option, that is option number D. So for option number D, it says A equal to 1 and B equal to 1. So take that, A1, B1. So therefore, fx is equal to cos mod of x cube minus x and mod of x sine x cube plus x. Now, we notice that we have to test for differentiability at x equal to 1. Now, when we want to test for differentiability at x equal to 1, we can say that by the virtue of option B, right? We already noticed that when A equal to 0, just change the color, when A equal to 1 and B equal to 0, right? So then what happened? This function give us fx is equal to cos of x cube minus x, right? And this function is differentiable. So we already proved that, right? So therefore, we can say that by the option B, cos of x cube plus x is differentiable at x equal to 1, right? Now we need to have the another function, right? So notice that when we talk about that 1 minus h and 1 plus h, right? Again, right? By mod x is equal to x and sine x cube plus x will be sine x cube plus x. Why? Because see that, right? In this two region, right? X is greater than 0, so this condition is always be true, and x cube plus x is always greater than 0. So using of mod, right, in this region, right, are not meaningful, right? So we can write that the function will be equal to x sine cube x plus x, and by default, right, by normal observation, this is also differentiable at x equal to 1. Now when I say it's differentiable, it's saying that it is differentiable in the neighborhood region, right? That's it. So therefore, both the function is differentiable at x equal to 1. So the sum of both the function will be differentiable at x equal to 1. And hence, fx is differentiable at x equal to 1 for a1, b1. And that's why option D is not correct. So that's why for this particular problem, obviously option A and B are the correct option. So see that if we know how to sketch that, right, the problem became much more easier and we don't have to spend much time to solve in this kind of problem. So that's why learn how to sketch a polynomial or any function arbitrarily, right, and then put your logic for differentiability, continuity and all. So then it makes our life more simpler. Hope you understood the problem. Thank you.